Dr. Givens coming at you, video recorded again. This is 2014 AP Calculus exam, problem number 3 on both the AB and BC exams of that year. It is the first of the non-calculator section of the AP exam, and although you will be allowed to use a calculator this year, it's also been written in a way so that you should not require the use of a calculator. And so it's probably a good idea to study on non-calculator questions because those will be likely to be more like the ones you will get. Now, take a moment, pause if you need to, read through this problem, and then try it on your own. I encourage you. And then we'll get to see my solution, and I'll talk you through it. All right, so I've got this graph transferred onto my whiteboard here. I've got the definition of g of x, which, so this graph is of f. G of x is a function defined as an integral function, an area or accumulation function from -3 to x of f of t dt. And like the human eye, my whiteboard has a blind spot, but unlike humans and their blind spot, I am painfully aware of this region that lacks vision, and so I will avoid writing in that. Part A just says find g of 3. Find g of 3. So let's start with that. And I shouldn't have to say this, but I'm going to say it. Make sure that you know the difference between the function whose graph you are given, f in this case, and the function that is asking you to tell something about g. It's not asking you to find g, the value of this graph at x equals 3. We need to work with g. So, and we don't have the graph of g directly. We just know g in terms of this graph. So g of 3, just plugging things in, is going to be the integral from -3 to 3 of f of t dt. All right, so if I go over here to -3, that's going to be this little dot, and +3 is here. So I've got to figure out what is this shaded area right here. Or I should say the signed area, because this portion will be negative. And this is more or less a simple geometry problem. So the area of this triangle, shaded red right here, is 1/2 base times height. That's 1/2 3 times 4. And then the area of this triangle is 1/2 2 times 4. And because this is below the x-axis, I've got to subtract it. It's signed area, so that triangle has area -1/2 1 times, and this goes over 2 and down 4. So when it goes over 1, it goes down 2. So the height of that triangle is 2, by similarity, by the slope of that line. And it's going to be, what, 6 plus 4 minus 1 is 9 square units. The AP exam doesn't require you to simplify answers, so if you just want to leave your answer like this, you will get full credit and you won't risk making an arithmetic mistake, which I hope I didn't do. You cannot leave an answer that involves an integral. That does not count as a valid unsimplified form, so we did have to go to this next step here. But this is perfectly valid, even if it doesn't sit well in your stomach. They will accept this answer. That was part A. Let's clear the board and start on part B. All right, I have carefully removed the red marks and the dotted line from the graph. Don't let anyone tell you these videos don't have a commitment to high production values. And part B says on what open intervals is the graph of g both, let's see, what did it say? Increasing and concave down. And give a reason for your answer. Justify your answer. Well, if g is going to be increasing, we need its derivative to be positive. To be concave down, that means its second derivative is going to be negative. So I'll just memorialize that information. We need g prime to be greater than 0 and g double prime less than 0. Well, what is g prime? Let's, right, again, f is not g. G is this. So if g of x is this, then g prime of x is d dx of the integral from -3 to x of f of t dt. When I differentiate an integral expression, the lower endpoint is constant, the upper endpoint is the variable I'm differentiating with respect to, unaltered, just constant and the variable. Then the fundamental theorem of calculus, second version, tells me this derivative is just plug that variable into the integrand, replacing the dummy variable t. Haha! So g prime of x is f of x, and therefore, of course, g double prime of x is f prime of x. Okay, so if I want g prime greater than 0, I need f greater than 0. So those are -5 up to +2. So g prime is greater than 0 on the open intervals. So it's the open intervals negative. Let's see, it's got an isolated 0. F has an isolated 0 right there. So g prime is strictly positive throughout this region and is non-negative at a single point. So if I imagine what g itself is doing, it's getting larger and larger, right as I'm integrating from starting at -5 going upward. The values are getting more and more positive at every moment, including at this value. So g prime is, what I should probably say is g prime is greater than or equal to 0 on the interval from -5 to +2, that open interval, which with an isolated 0 at x equals -3, right there. So f, or rather, so g is increasing on that entire range of values. It's also increasing at -3, and this is a little bit counterintuitive, but I want to explain why that is, right? Even though the derivative g prime, which is the same thing as f, is 0 at this point, it's true that for any 2 points separated by some distance, either around that point or including that point, below, above, around, including 2 different points, the value of g will have gotten bigger when I move from that left point to the strictly different right point. And that's what it means to be increasing on some interval. So it is increasing on this entire interval. Now I need to know, where is it going to be concave down? So I need the second derivative to be negative. That means f prime, the derivative of f, needs to be negative. So I got to look at the slopes of this graph. Here, my graph of f is decreasing, so f prime is negative. Right here, f prime is positive, and right here, f prime is negative again. So the intervals where f prime is negative are here and here, and well, also there, but that's not part of the place where g prime is positive. I've run out of room, so I'll just write here g double prime is less than 0 where f prime is less than 0, comma, come all the way back up here with me, which is -5 up to -3, union together with 0 to 2. So g is increasing and concave down on the intersection of those values, which is -5, -3, union 0, 2. And let's now go to part C. C gives us this function h of x. This is part C. H of x equals g of x divided by 5x. And we are supposed to find h prime of 3. So before I can find h prime of 3, I need to find the general function h prime of x. And h is defined as a quotient of two functions of x, g of x and 5x. The AP exam loves to mix up explicitly defined functions and functions that are only given a variable name. Well, actually, we do know what g of x is. So let's try it out. It's going to be low d high less high d low all over low low. So that's low d high, the derivative of g of x, g prime of x, less high d low, g of x times the derivative of 5x is 5, using the quotient rule here. Low d high less high d low all over 5x quantity squared. So that's, let's see, 5 times 3 times g prime of 3 minus 5g of 3 over, sorry, what is h prime of 3 is equal to this. 5 times 3 quantities squared. All right, 15. G prime of 3 is just, remember g prime of x is just f of x, so g prime of 3 is f of 3, and f of 3 is this point here. We've got 3, -2. So f of 3 is -2. So that's 5 times 3 times -2 minus 5 times, what is g of 3? Well, we just calculated that conveniently in part A, and it was 9. Now I remember, 9. So minus 5 times 9 all over 15 squared. And this time, I'm not even going to bother simplifying. I know the AP exam will accept this answer, and I'll stop right there. Let's do part D. Okay, part D defines this new function p of x as f of x squared minus x. And it says find the slope of the tangent line to the graph of p at the point where x equals -1. Okay, well, the slope of a tangent line is a derivative. So it's asking find, in other words, find p prime of -1. Well, I'll start by finding p prime of x, the general derivative. And what I've got here is a composition of functions, f applied to an inner function that is x squared minus x. So I'm going to have to use the chain rule. it'll be the derivative of the outside function evaluated at the inside function. Derivative of f is f prime evaluated at x squared minus x times the derivative of the inside function. Well, the derivative of x squared minus x is 2x minus 1. Cool. And that's p prime of negative 1 then equals f prime of, now plug in negative 1 for all of the x's. So negative 1 squared minus negative 1 times 2 times negative 1 minus 1. All right. That's going to equal, okay, negative 1 squared is 1, minus negative 1 is 1 plus 1, that's 2, so f prime of 2 times negative 3 right there. What is f prime of 2? Well, this is the graph of f, and so f prime of 2 is the slope of this graph when x is 2. And that's looks to me like that's a linear portion of the graph, and the slope is over 1 down 2, we saw earlier. Rise over run, or over 4 down 8, right? So that would be a slope of negative 2. So that's f prime of 2 is negative 2 times negative 3, and the answer is 6. Awesome.